That's there. That's good. That's good. That's good. I think I'll be able to navigate these things. I'm worried about the size of that.
Alright, you guys give me a second here. I want to grab some stuff. I'll be right back. And then we'll start. We're continuing with methods. And we're going to look at how we can use methods as libraries. So we had created a method earlier in the class. We're going to create another class and we're going to point it to the, what was it? We called it Max. Yeah, because I just said Max, like it was some person.
Oh yeah, that was last class. That's right.
And so we'll look at talking about Max from other places. what we get when we have when our classes all day. I have to run around to do small shit. Sorry. All right. So we had created a method last time, and what I want to do is I want to look at the reuse of a method. So I'm going to come back over here and just get a little bit look at our friend Max here.
Oh, it's supposed to snow tomorrow? Lovely.
So Max was a method that we created inside of the class that we had. So here I had Max as defined as an integer and Max defined as a double.
Oh, I remember.
And we had put this inside of our class, which was test max. So we have this class called test max, and we had a main in it that we could run. Well, I'm going to create a completely separate class in chapter 6. So I'm going to come over here. We're going to make a new class. Now, this needs to be in the same package that we made Max in. So some of you guys have been using in-class programs, right? You've been using different. I've been using one for each chapter, right? I make a new package for each chapter. But some of you just have a package for what you're doing within class. So I am within my chapter 6 package, and I want to come over and I want to make a new class. And what we're going to do is we're going to call this external methods.
No, not new. It is.
And let me see here. There's cancel, new class. Finish. I have. Oh, I can look back here. Sorry, I've got my screen split a little bit, so I'm working on finding a way to get these all on one screen. Let me just finish here. Where did we go here? Finish. Come back over here. That's better. It's a little bit off the screen over here. All right, come back over here. And so what I want to do here is I'm going to just repeat what I did with Max before.
Yeah, my
So-
computer's lagging.
I am going to create an integer. Okay. Well, I'll leave this up. A equals 5 and an integer. I'm not going to ask for user input right now. I'm just going to borrow what I did before. B equals 7. And if I remember with test max, right, in test max, I had an integer version of it, and so I'm going to reference test max. So the class that I had it in was called test max. And I'm going to go integer. And notice this wording I did here. So, whoops. I can reference another class. As long as it's somewhere where my Java compiler can see it, I am referencing the class that's in my package. So in this main, I don't have Max. Max is back in this class. But I can run it from this other class by referencing. Notice the naming convention I'm using. I'm using the class where it is and the name of the method. Just like we do with math.pal, right? Java can see all the classes that are in the math, or all the methods that are in the math class. We reference the math class. Java finds it for us. Well, here I'm referencing one of my previous ones. Let me make sure my syntax is correct. So where did I go? Come back here. And it works. So you can start taking your code and things that you use often in a set of programs or amongst different programs, you can build classes to contain them all. And this is kind of why we have the idea of the package. Because if you have the package, you can kind of if you have multiple programs that might need to run at different occasions, but they're going to access the same methods, you write all your methods in a class for those methods, and then you can put the programs in the package elsewhere. So it's a way of reusing code, and Java's pretty good at maintaining the links between things within a package. So here we have our method, but it's not within the class we're working with. We just have to point to the class that it came from. We okay with that? All right, it's some flexibility that we're going to add to things. All right, let me see if I can get this up front. Yeah. So that's what we mean by reusing methods from other classes. And this will become the mentality that you'll see, like, don't reinvent the wheel, don't write the same code over and over again. Yes?
What was your last class? Can you go back to the Mac so I can take a quick picture?
Yeah. Hold on. Come here, Mr. Max. Where are you? Why aren't you showing? Here we go. So we called it Test Max. And do you have everything down to result num2?
Yeah.
All right, let me go put result num2 at the top. There's two of them. Let's see, which one did you have? There.
That one, yeah.
Yep. So that's the end of the first method. We did it as an integer.
Yep.
Then we did it as a double here. So that we overloaded it, and then in our main, we used it both ways.
Thank you.
So, and there we used it as a double. So we used it as an integer and a double
Okay.
in main.
I had an issue trying to log in, because it was lagging.
Oh, that's okay. We're still here.
So what I missed?
Nothing really. We just showing that we can reuse a class from outside of that class if we use the class name, or we can reuse a method if we point to the class that it's in, so that we don't have to write all our methods in a piece of code. And you'll find as your code gets bigger and you repeat things through different programs, right? You know, let's say you have someone that's entering data, you have someone that is entering the data into a database for contacts, and then you have someone else reading it. Well, how you read and display contact information will have similar functions, similar methods. So if you share the methods between the two parts of the application, you don't have to keep rewriting that code. So class can also become a container for code that your different programs use over and over again. There we go. All right, so methods help us with not reusing code. Now, in our current method, we had that it was of a type integer or it was a type double. It had a return type. We can also use the void type, and the method itself will not return a value. This is really good for common display, common write, where you don't need a value return for it. So if I have something that's going to display often, or it's going to write to a file, but I don't need a value return from that write, void is the proper method to use. So we're going to look at setting up a void method here. Let me, yay. Sorry, I've tried to change my display settings here, and I'm having a weird when my mouse moves from one to another. So
you click it, import, and then text max?
Nope. No. You don't click import. You just name it. The class dot the name of the method.
Yeah, that's what I was confused about.
Right. We were not using any features in the IDE to pull it across. We use our naming convention. There's my cursor. There we go.
Oh, okay. I just wasn't sure like what the key is to that you use. What you type.
All right, so I want to focus on creating a void method now. So again, since we're testing things here, I'm just going to say that we're testing a void method. All right, I'm not giving any great names here for this stuff. And we'll come here. All right, so what we're going to do here is I'm going to create the method first, and we're going to make a void method. So I'm going to come outside of main. Still not used to, sorry, I got two cursors here. Please forgive me as I move back and forth between the two screens here. All right, so here. Where's my, there it is. All right, so this ends my main method. And so in my main method, I'm going to be referencing a void method, but I want to create the void method below it. So I'm going to create the void method first. So we're going to create a public. Void. And in this case, I'm going to say print grade. We're going to print the grade, and what I'm going to do is I'm going to give it a double called score. So in my signature, I am returning void or nothing. This does not return a value. It does take in a double. So I can still overload it, right? I can take in integers. Remember, our methods can be overloaded as long as the signature changes, and the signature is all of this. So I can still take in different arguments to overload it. But for right now, I'm going to take in a double. And then what I'm going to do here is I'm going to do all the if statements for printing a grade. So if score is greater than or equal to 90, whoops, 90.0, then we'll write to the system A. Else, if the score is greater than or equal to 80. All right, so I'm doing a letter grade conversion, but I'm going to do it all inside of my method. So I'm going to continue on filling in each of these here. Bear with me as I continuing on. Whoops. All right, so we're going to continue our else ifs as we wedge our way through our scores to get all my letter grades. Whoops, not println, println. Son of a bitch. There we go. Please bear with me as I'm having some weird typing right now. Like, remember how I said I would like to split my monitors between the two things? Well, I've split my monitors a couple of different ways right now, and I'm just getting used to how the cursor is working So I'm not looking at my laptop, I'm looking at the screen here. I'll make it work eventually. But if you notice, I'm making a lot of extra typo thingies than normal. I'm not saying I don't make them, I'm just making more than the norm. And what do I have to end it with here? An else, right? Because I don't need to do an else if, because I've bottomed out. Alright, so there's my else. And so, notice I have no return statement, but I've reached the end of my method. Whoops, I don't want the up arrow. So, this method doesn't have any return. I'm going to come up here in main, and I'm going to reference this method in main. So let's see. System.out.println. The grade is, I'm going to put a space. And now I'm going to call my new method, print grade. And I'm going to send it, how well do you think I did? Rate me out of 100.
92.
Oh, you're too generous.
75.
90, we'll do a 92.3. We'll come back in. So this now references my my void method. And I get the up to the screen. Notice we've created something now that doesn't need to return a value. It can handle a whole set of sub-functions. If we look back at some of the programs we did where we're printing things to the screen repetitively, calling a function to do that whenever we need to can help tighten up our code. And so let's see, I'll come in here, let's say we'll do a 71.0. I'll run that one, and I get to see. So we've put the whole dealing with the screen for whatever the grade is into this method, and so now we don't have to have that in any of the code. You can do a whole bunch of like menuing systems, things where you might want to repeat. We think of the game that we played where we want to get certain value from people. We can take processing the value from the keyboard. We can take asking to enter something. We can make them void methods. We can make them return methods depending on what we need. But there's ability to take chunks of code that you can see running often. Right? If I had to work my way through like 50 grades and I needed to print out each one coming through, well, now I can put this into a for loop. And the for loop can deal with it. And any special formatting I need to do only needs to take place in the method. If I need to change the formatting of something, so if I saying that print grade, I need to do this all in lowercase, right? I could come in here and I could change the chars to lowercase. I could force lowercase. All right, you push all of your formatting. You force all the places where you're dealing with the one thing, which in this case is printing the letter grade. You push it into one place. So any change that you need to do to it can happen in one place. Does that make sense? We're doing methods, and that void methods in their own right give us things where we don't have to worry about them calculating a value. All right, so that's our void methods. All right. Well, one of the things we can do is we can pass parameters into the method. And we've already been passing in integers or doubles, but the methods themselves can take different things. So here, let's read this code. Right? Now that we have an idea of what a method is doing, public static void, so it's not returning a value, and its name is going to be endPrintLine. It's going to take a string and an integer. Now what it will do is it will loop from 0 to n minus 1, so it'll loop n times, and it will print that message. So this is a way of repeating a string encoded into a method that can be used. And it doesn't need to return anything because it's printing it directly to the screen, hence the void. So let's run this. Well, here's the suppose, right? This is asking you to read the code. I'll try this. Answer yourself, what do you think this will do? What do you think print line message, what will this print?
Welcome to Java.
Welcome to Java 5 times. On separate lines, because it's using print line, right?
Yeah.
Like if we remove the print line and just did a print, right, it would just repeat coming across. All right. Do me a favor. Make a class, right, to contain this. So let's come over here. I'm making way too many classes today.
That's like the fourth one.
This is the second one. So we'll go to new class, and we'll say, what multi-print? What do you want to call it?
Yeah, multi-print sounds cool. Let's do that.
Mm-hmm, right. What I want you to do is I want you to take this. I want you to put this into multi-print. You put it outside of main. You either put it before or after main. So create this in multi-print. And then make multi-print do these. In the main, answer these questions.
Do you want us to write that third one, or should we not bother writing
Well, why wouldn't you write it?
that? Well, because it needs a string, then an integer, and that's an integer, then a string.
So what do you think it's going to do?
Not work.
How is it not going to work?
Doesn't notice or something.
I don't know. So you're right. This is the wrong syntax for what we defined. But what's it going to do? So type it. See what it does. Right. That's what I
think it must be an error.
Right. That's fine, and that's good. But see what the particular error is. Does that make sense?
Mm-hmm.
Right. No. Right. We all know what we want it to look like. Right. But when it doesn't look like what we want, sometimes seeing a particular error helps. So I'm going to try to catch up with you guys here. Where is my... Damn, still not used to this yet. There we go. So you see that you get a particular type of error, right? Does it tell you that the arguments are incorrect?
Yeah.
Yeah, right. And that's worth knowing. Because when you get error message, right? Error messages, and print, what's it asking for? And print. Is everyone comfortable getting this code in? Do you need me to run it?
Yes.
Yes, okay. That's what I needed to know. Looking, right, because we had this code up here, and I just want to make sure I'm getting it right. End print line. All right, I think I can get the rest from there. End print line. Line. And it was string called message, and then integer n. And then n, it was a for loop. For I equals 0, I less than n, I plus plus, system dot print line message. I think that was all. Nice and simple. To the point.
Oh, okay,
What am I
that's
missing here? The method print line string. Oh, I print line system dot out. Sorry. All right, there we go. And where do I need to call that an integer? All right, so let's come here. And what were we asking? We were asking if n print line. So the questions we were going to ask of it was, can I print welcome to Java, comma 5, computer science, comma 15, and 15, comma computer science. So I'm going to test the first two of these. So in print line, welcome to Java, comma 5. And we said we'd get 5 lines of it. So where is my fucking cursor? There we go. And did I get 5 lines of it? Yeah. All right. And then what was the next one? Computer science and 15 times? Is that correct?
Yeah.
All right.
Yeah.
Do you need me to type that one in? I think the bigger question was 5, comma computer science. Correct?
Yeah.
All right. And so we rightly saw that this should error because our arguments are in the wrong order. When we define this with the string first and the integer next. In fact, Eclipse is smart enough to tell us something is going to go wrong. Right? But if you're not in an IDE, we run this, we'll proceed, and no. And so we get this, the method type isn't matching, right? For the arguments. Did you get an error in red, or did you get this?
It was in red.
Yeah, it was in red. So I think my debugger is trying to protect me here from in red. But the general idea is that this is having a problem because this does not match the signature for this. Does that make sense? All right, so, and that's what we're really trying to look at here. All right, let's continue on with our foray into methods and looking at all the different things we can do with them. All right, so pass parameters, we can have void, we can have it return. Let's see if I have this here. Sorry, this chapter has a lot of example code.
What did I do wrong here? I think I might have made a typo somewhere.
In what way? What's it doing?
It just says method endprint ln int string is undefined for type multiprime.
For what?
For the type multiprime.
Have you been able to run it once?
I haven't even done it yet.
Okay. That's. Anyone else still working on that slides method? Yeah, let me know this. Right? Yes, please. Let's go back. All right. So let me go back on these here. Here. So this is the method that you want in Eclipse, and these were the things we wanted to run. Now I'm going to bring my particular version of this up here. But the thing to note about mine right now is this line is an error. So I'm going to fix this line right now. And I'm only going to make it print out twice because I have limited screen space here. Terminate. Let's restart. There we go. Because of the error I had before in debug mode. Okay. So I'll leave this up here. What you need in your multi-print is outside of main, you need this void method. And then inside of main, you need to call it.
Oh, I see what I did wrong. There's a typo here.
Only runs it once.
Yeah, it does. Because you didn't put the fork.
Yeah.
Oh. Semicolon goes inside.
Yeah.
Oh no, it doesn't matter.
Thank you.
No problem. That was you know like you know it's something small and you're looking at characters on it.
Yeah.
Austin, did you get it run?
No.
Okay. Much of it. Computer Science 5, so we get an error up there. I'll be over in a second.
Okay.
So n print out n, that's right. For line is right. That ends the for statement. That ends that. Go with static void main and print out n. Computer Science 25 is highly overflow. This is better something small. No, any of those. I'll just go back. Yeah, you're good. Click on the white screen. Just put your mouse over it. Don't click on it. So multiple markers of this science cannot be resolved to a variable. Okay. Here's computer science. So it's reading. So somewhere it's not reading that string properly. So let me see what's happening here. It's almost like there's an open quote anywhere. So I would delete both quotes. No, just the quotes. This one. Both of them. The one before computer science and the one after. Oh, okay. No, retype it. That's fine.
Oh, I see.
Quote, comma. these here, something was wrong with them. They were pointed in weird. Some of them was typed not the. It just was the wrong characters on it. Couldn't tell you until we deleted them going through. But that makes sense. Thank you. Make sure it runs.
Now I think I fixed it on my own.
Runs. Looks good.
Yep.
Yeah, good toys. Okay.
Anyone else?
Yeah, I had a typo in there. That's what it was.
Well, no, that's what we were looking at. So, one of the things we're starting to notice now, as we get some longer things, some different, you get the wrong character in, you don't notice it, right? Because didn't we have a hunt for what was it, a comma on one of your earlier programs? We were hunting for a comma in your numbers, and sometimes the error doesn't tell you where the thing is. And in one case here, we had a semicolon that was over in the wrong place. And so sometimes that's the things we got to look for, and you only really get used to finding those when you actually mess up, right? So one of the things we have to learn.
Try one of the other things on.
All right, so what we're going to do here is we're going to look for kind of how we can pass something by value. So let's look at this is really I'm gonna put the code up. It's example code from the book, and we're gonna look at what it does. It's not on the slide. The slide references it, so I'm gonna make another program in here, another class. And we're going to call it increment, which is the example in the book that I'm using is called increment. So if you look at your book, and what we're going to do is we're going to break down what is happening here. So I want to bring this example over from the book. If you ever get a chance to work with multiple monitors where your cursor flips over to something like a big screen like this, and you like if you see me looking around, I'm like, you're so used to just like slowly moving it, and I'll move it here and it like zaps across the screen. So if you see me sometimes going like that, it's kind of trippy right now. On that it's I'll get used to it the more I use these. All right, so what we're going to do is we're going to make this thing called increment. So we're going to make I want to put the method down below main, just because your book does that in a lot of these. Again, I want these to look like the book. So we're going to make a void, and we're going to call this thing increment, and we're going to give it some integer n. And we're going to increase n by 1. And what we want to do is look at an inside method. So we're going to peek at what it's doing inside the method, and we're going to peek at what it's doing outside of the method. So here I have a method. I'm going to pass a number, I'm going to add 1 to the number, and then I'm going to print it. All right, pass the number, add 1 to the number, and print it. So, number before. So I'm going to create a number, I'm going to look at it, then I'm going to send it to the method. The method's going to increase it by 1. And then in my number after. Making sense? We're peeking out at what's going on. How did I end up with single quotes?
for space.
There we go.
Plus X.
Oh. So, what do we think will happen? Let's walk through this before we run it. For those of you that have already ran it and peeked. Nah. Alright, so I set x equal to 1. So, what's it going to print here? That's weird nomenclature, but yeah. Alright. Then I'm going to increment. So it's going to drop down to here. It's going to add 1 to n. So what's it going to print? No. And inside method. Then I'm going to come here, and what's the number after going to be? Any guesses? Or who has already run it? Because they were going really quick. All right, you don't answer. I'm taking it you did by the way you laughed.
No.
Oh, no, you haven't. So what do you think it's going to print? So we know it. We were saying it's printing 1 here. It's going to print 2 here. What's this going to be? Okay, run it, and then answer the question. If you're not sure what it does, then run it and let the program answer the question for you. Get the hell back here. Why am I in edit modes? Go away if I hit the wrong button. Where'd my run button go? Alright. Am I in the right place? There's that.
Oh, is the screen too small? You can't see.
No, it's, display view. Let's go to run. It's not opening the right things. Spelling, window, where's run? Alright, let's click on this. This is what I get for changing windows on me here. Alright, let's come back to this. There's Eclipse. There we go. So 1. We did nothing to change x. Methods create their own variable space. If I pass something into a method will have its own memory for everything in it. It will do everything inside of its own memory, and then when it returns back out of that, this wasn't touched. If I need to increment this, or I need this to be touched, increment has to return something. So let's see if we can get a return out of this. Public integer, public static integer, increment integer n. N plus plus return n.
Public static integer increment.
But here I have a problem. These really have the same signatures going on.
Yeah.
Alright. So I've got to choose what this is doing. Alright. So if you have void methods, you lose the ability to get returns from them. Now, let's how could we make these two things work the same?
Get rid of void.
I want to get rid of void, but I also want to have the ability for void to work, right?
Yeah.
Well, this means this is going to return an integer value. So I want to comment out the void. Oops. Oh, motherfucker. Sorry, I didn't say that out loud. That wasn't me.
It happens. So, //. Oh, okay, I didn't know you could do that.
All right, so I've commented out the void version of it. Notice I haven't, well, let me make this work exactly like I had it before, so I'm going to put the out here. Notice I've got the exact same behavior when I run this. This is doing something different. This is returning a numerical value. Void wasn't. Does that make sense? Right? This is it. And here's where the difference was. Up here, when I call increment, it's returning a value. I don't have it going anywhere. I could come back, and if I say x equals increment, I'm going to update my x value. Does that make sense? That by the difference between void and having it return a value, well, sometimes you might make a void thing and you realize, hey, I actually do want this to update the x value. You're going to have to rewrite that method. And now, when I come back in, I can reset x. I can have it return value. All right. So voids are great for accessing input and output, and sending things off in one direction, right? But you lose the ability to get a return type from it. I have a tendency to avoid voids. I tend to always return something, so that way I can return error codes. There are things I can do. But void is not a bad idea to use, especially when doing multiple display things. When you need your display format to be the same in multiple places in your program, having a method that returns void and just takes care of organizing your screen layout is good practice, right? I just tend to, if it's successful, I'll return a 0. If it fails, I'll return an error code. That's something as once we get into objects, we'll see more about having error codes with things like that. But void is a good thing, and you want to practice void methods where you can. We okay with that? Mm-hmm. And do we see how, I couldn't get a return value from it in void frame. I couldn't overload it because the arguments were the same, so I had to go in and change it. But we could get both functionalities out of it. Just switch back over. Oh. What the hell?
Yeah, what the heck is that? I don't think it's
all my slides went away. 2 of 5 of 74.
Oh.
And it must have been when I was is that what was happening when I wasn't hitting run? Let me reload this. Hold on. Damn, it's one of those days.
I mean, can you just re-download the slide?
I'm not going to re-download it. I'm just going to reopen it. It didn't save it unless I hit save by mistake. Then I'm in a horrible place if that's what happened.
Let's hope you didn't.
Yeah, worse things have happened in life.
You can just re-download it from Blackboard.
Yay! There we go. Bum, bum, bum. My guess is when I was swearing at that weirdness at not running, it was like deleting slides in the background. That's fun.
Yeah, I didn't even know you could do that.
Do what?
Screw up the slide thing like that.
Well, I was probably clicking on the wrong menu bar. I don't know. It all works out. All right, let's see. We reused methods, and now I just need to get back to where I was. We passed by value, modularized and code. Yeah, so now let's look at some examples. Yeah, we have 20 minutes. I'm going to talk about both of these. I think I'm going to do greatest common divisor. You guys ever had to work with LCDs and greatest common divisors in math class? right? So what we're going to do here is we're going to kind of think out a solution that would be a greatest common divisor method, right? We want this to be a method. Anytime we would need to find a greatest common divisor, we don't want to keep doing that code. We'll find that there are certain things that you do that once you do them, you need to reuse them in other things. So it's good to have, you know, a GCD, greatest common divisor method. Computers make it nice to do greatest common divisors or some mathematical things with integers because we have that modulus function. We can divide and see if we get a remainder, right? Right, when we use that percent sign for division, right, 6 modulus 4 is going to give me a 0. Or, no, I'm sorry, it's going to give me a remainder of 2. Guys, remember what I'm talking about? N modulus 2, right, gives me the remainder divided by 2. So if this equals 0, then my number is even. If it equals 1, my number is odd. Right, because modulus division can do that. Well, I can do the same thing, n modulus 3, and I can go through a list of numbers and find numbers that are divisible by 3.
Oh, okay.
Right? Because if this equals 0, it's divisible by 3. If it equals 1, it has a remainder of 1. If it equals 2, it has a remainder of 2. And so when I do this modulus function, I get these collection of remainders on it. And so I know when the remainder is 0, whatever I was dividing by was divisible by that thing. And we're looking for a greatest common divisor. We have some ideas that we can use in here. All right, so what do I want if I think of a greatest common divisor between numbers? So let's see. Well, let's take an example of greatest common divisor. I need a good example number. Let's do 27 and 18. So, what is the greatest common divisor of 27 and 18? Well,
9.
9 times 3, 9 times 2. So we have to find some way of collecting those. Well, what if we did 60 and 30? Right? 30 and 2, 30 and 1. So the actual number is the greatest common divisor of those, right?
Oh, yeah.
So we need to find some way to take two numbers and then find a greatest common divisor for them. All right, so if I have two numbers, well, what did we do? We have this problem being human that we look for patterns, right? We're not doing an AI version of this, right? We're not doing pattern techniques or, no neural network. We don't have, the computer going in and just dividing by every possible number and then keeping patterns out of it. Right? If I wanted to program an AI to do this, I would have the AI do the algorithm we're going to do over and over and over again. And what's the thing that you should start to realize? 27 was divisible by 9. Isn't that the thing that was kind of inning in the back of your head?
Yeah.
Right. You've dealt with this number enough. You kind of remember there was a 9 in it. And that's what a neural network is you've worked on a pattern enough that you remember certain patterns. If I ask you for 424 and 318, any good patterns out of that?
Not off the top of my head.
How about 424 and 328?
I mean, I'm not familiar with that high.
Right. That's
numbers,
right. So we have to kind of think programmatically about these. All right. So if I'm going to have two numbers that I'm going to enter in, well, what did I do? I kind of can work my way through. Well, we said this was divisible by 9, and then we asked ourselves, was this divisible by 9? Well, I knew this wasn't divisible by much else. That's my so. Well, let's say, is this divisible by 10? Is this divisible by 11? So, well, is this divisible by 1? Yes, it is. Is this divisible by 1? Yes. So, 1 is the greatest common divisor when I first look at it. And I'll go, hey, is this divisible by 2? No. Is this divisible by 2? Yeah, but it doesn't matter, right? They're not sharing 2 because this doesn't have it. I could kind of work my way through every number from 1 to 27 and 1 to 18 and find the ones that are the same.
Yeah.
Does that make sense? So we kind of want to work our way from one number to the other number.
Isn't 1 technically the greatest common divisor for everything over?
That's the
over
least.
0? I mean, least. I mean, yeah.
Yeah, not greatest.
Yeah.
You said greatest. Technically,
Yeah, I
it's
didn't
the
mean to
least.
say that, yeah.
Everything you can factor out of 1. So
Yeah.
much so that we don't write factors of 1 coming up.
Yeah, because it's pointless.
Not necessarily. Sometimes it's useful. Especially when I write 1 like 3 over 3.
Yeah.
Then I can change my denominator on a fraction.
Yeah. Simplify.
We can use multiplying by 1 to change form. Just like we can use adding to 0 to change form. It's just having different forms of zeros and ones. But for us here right now, I guess we want to kind of work our way through all possible divisors. Right, I could go through all the ones. Right, what I was doing here, 1, 2, 3, 4, 5, 6, 7, 8, until I no longer was within these. Is that okay? Right, so I'm going to have some number that I'm going to call my greatest common divisor, and we'll call it K. And we'll start at equaling 1, because we know at least 1 will be for both of these. And what I want to do is I want to keep going until K doesn't matter anymore. So when does that happen? Well, we'll make a while loop. And we'll say K is less than or equal to, what am I going to call them? I guess I'll call it number 1 and number 2. Right, will be my integers coming in. So when I was going through this one, right, when I was going through these, I could do 1, hey, that's a common denominator, 2, that's common, 3, that's common, 4, this one's not divisible by 4. Look at 5, they're both divisible by 5. So I could work my way up, 1, 2, 3, 4, 5, until all of a sudden, once I hit 30, I'm done. Because 31 isn't a divisor, right? So I have to, whatever my two numbers are, they have to be smaller or equal to the smallest one of these. Does that make sense?
Yeah.
Yeah. So I could say that, well, if I don't know which one is smaller, I can make an and out of it. So as soon as the first one gets bigger than one of these, I'm done. And now I can walk my way through all the K values. And so let's see, what can I do here? What would I think about walking all my K values? I have to look at my logic here. Well, what do we want them to be? What do we want them to be? Well, what we want to happen is if n1 factorial k. What does it have to be? If this is a divisor, what does the factorial have to give me when I divide? 0. And if they're common?
1.
No, they both have to be 0. All right.
Oh, yeah.
If I take some value, and these are both k, sorry. So if I start with 1, and I divide both of them and I get 0, then in hey, k, now I'll say my GCD is k. All right, that'll be whatever my if statement does. Else, don't do anything, right? So I can keep track of my GCD. Okay. Come through here, I do my modulus, right? And if they both return no remainder, then I update my GCD. And then I try the next number. And I can keep working my way through. It's exhaustive, right? It's not how you and I would do it. We try to hunt a pattern. But for big numbers, we have to what we have to factor, then we have to do all this shit to try to find these. Where a computer can just work its way up to the big numbers. Let's try that. Does that make sense? And what this can do here is this can give us a piece of code that we can use to find a GCD. So let's see here. Let's make our GCD code. Told you today, yeah, we got 15 minutes. Today would be the day of many classes. But I want to show the usability of methods.
So same class, right?
What are you doing? Wave at least. I missed. Sorry, I have to make fun of like the two people I only see like once a week because I'm always in a class. So, sorry. So we'll go to new class, and I don't want to call this GCD because we might add some more methods to it. So let's just say math tricks for right now. We all right with that?
Yep, sure.
Good. You guys are very generous with my stupid names for things. You are very, very generous on that. All right, so what I'm going to do here is we're going to look at the method for our greatest common denominator. So public static, and we're going to return an integer, right? Because this thing is an integer that we're asking for. And I'm going to call it GCD, and I'm going to need to give it integer number 1 and integer number 2. So here's where I'm going to get in my integer number 1 and number 2, and then I'm going to do this thing where I'm going to try to find my GCD. So keep hitting, sorry, cursor problems. So I'm going to have an integer called GCD, and I'm going to set it to 1 because we know 1 is, as Austin said, always the smallest GCD.
Yeah.
And then I'm going to have my guess for the next one also equal 1. And I could start at 2 if I wanted to, but I'm going to make this. All said and done, I'm going to return GCD. So what I need to do in the middle is I need to check my values. So the first thing I'm going to do is while my guess is less than and equal to the first number, and whoops, bad typing day. My guess is less than or equal to the second number. I'm going to look. Remember, if my guess goes above one of the numbers, it will not be divisible. So we make this our gatekeeping here. We check what our guess is versus the numbers, and guess is going to be the thing that we're going to increase while we can. And so now I just need to check, is it evenly divisible by the guess for both of them? If so, GCD equals guess. So I update it.
Percent.
And then what I just need to do is I need to increase, whoops, not get my guess. I need to increase my guess. All right, so it's not a huge process. It's definitely not how a human would do it, but it will work on a computer. So I have this as a method because if I need anything that needs a GCD, right? We've used GCD for simplifying fractions before, right? I can just re-pull this code. But right now I'm going to test it. So I'm going to go into main and test it. So, and I'm going to be typical Jeff on this. Please, here we go. I'm going to come back up here. What are we going to do? We're going to import java.util.scanner. I'm just going to type in numbers and I'm going to find out GCDs. All right. So all those weird numbers I asked you, we'll let the computer find the GCDs for them. All right. I won't have to do anything with them. So system.out.println, enter 2 integers. We're going to find the our greatest common divisor in all of these. So let's see, scanner input. Sorry, I'm not coming up with a better name ever, so I'm just going to keep calling them inputs. All right, starting to get some standard things we're doing here, right? So I'm typing quick on this, and so my first number is going to be the first number I type in. Next int. My second number is going to be the second number I type in. And so the greatest common divisor, GCD of %d and %d. I'm going to change this to a printf. Is %d. So notice I put 3 placeholders here. Right? GCD of some number and some other number is. I'm just going to use my printf to keep track of everything for me here. And so in that, let's see, number 1, number 2, and then I want my GCD method, give it number 1 and number 2. Let me sorry, this what I want to do here to make this a little more visible is I'm going to do it like that. You okay with that? To make it more visible, I'm splitting it on 2 lines on the parenthesis statement. So I'm going to use my printf statement. I'm going to say the GCD of number 1, number 2 is that function I defined. Now I'm going to be able to use this anywhere I want. I'm just going to test it. Let's see if I can run this here without killing. Enter 2 integers. So let's see. I did 27 and 18. 27, 18. Hey! I'm liking that. Let's do it again. Come back here. Do it again. What was the other ones I did there? 60 and 30?
Yeah.
It does able to hit it when the 1 is larger. So, damn, this is the shit I wish I had like in middle school.
Oh yeah, what
You know?
easy.
Well, what was the one I asked of you? 424 and 328. Right? All right, isn't that the one I asked and we're like, what the hell?
Yeah,
8. I knew it had to be some multiple of 4 because 424 is divisible by 4 and 328 is divisible by 4.
8. Yeah. Much faster than a person could have done it.
Depends on the person.
Well, yeah, sure.
definitely faster than me. Let's see. What would be an interesting number? All right. We'll leave this here. Keep reading. Look at the example methods in here. They use this then to help find a prime number. And prime numbers are really hard.